Now for the difference, f minus g, I'm going to have 3 absolute value 2x minus 5 minus absolute value of 3x minus 4. We're finding the same common denominator like we did up here. That's going to turn out to be 3 over absolute value of 2x minus 5 minus absolute value of 3x minus 4 multiplied to x minus 5 all over absolute value of 2x minus 5, because remember that just like what we did up here, we have absolute value multiply another absolute value. So we multiply the two inside expressions inside one common absolute value. So that's the same thing we did for here, except I just did not write out the steps. But anyway, that's going to give us the same result. But now we got 3 minus absolute value of 2x squared minus 23x plus 20 all over the same common denominator, absolute value 2x minus 5. Well, that's going to be equals to 3 minus parentheses, which is very important, 6x squared minus 23x plus 20 all over absolute value of 2x minus 5. So there's an invisible not positive, negative one on the front. So distributing it to each term on the inside, I'm going to have 3 minus 6x squared plus 23x minus 20 over absolute value 2x minus 5. Combining like terms by keeping negative 6x squared and plus 23x, and just combine the 3 and the negative 20, I'm going to have, kind of out of room here, I'm going to have negative 6x squared plus 23x minus 17 divided by absolute value of 2x minus 5. So with the results here, let's find all the points of discontinuity of the difference of f and g. Well, all points of discontinuity at every step of this simplification process is going to be the same as what we did up here, because over here we have the denominator absolute value 2x minus 5, but we found at the beginning of this video that x cannot be equal to 5 over 2 from this absolute value function. So x cannot be equal to 5 over 2 at this steps. And same thing can be said for this step. X cannot be equal to 5 over 2. X cannot be equal to 5 over 2. Same thing, and same thing. So really all of the restriction at this is that x cannot be equal to 5 over 2. What about the product of the two functions? Well, the product can be found by 3 over absolute value 2x minus 5 multiply absolute value of 3x minus 4. Why is that minus 4? Yeah, that's minus 4. But hey, this is more straightforward. We got 3 times absolute value of 3x minus 4 all divided by absolute value of 2x minus 5. And we cannot simplify any further, so we are good on this. So all of the points of restriction at every step of this simplification process for the product of f and g, it's just going to be same thing. X cannot be equal to 5 over 2. And x cannot be equal to 5 over 2. And so all of the points of restrictions for the product, just this. Now what about on the number line? Now what about the domain of the sum difference and product of f and g? Well, earlier we have the number line, and we have 5 over 2. And we know that the domain of the function g is all real numbers, like this. And the domain of the function f is all real number, except x cannot be equal to 5 over 2. So, oops, this is the function g, my bad. So, to find the domain of the sum of f and g, what I like to do is that I like to take the point of discontinuity, tracing from the point of discontinuity of the domain of the function f back up to the main number line. Because by doing that, I can tell right away that the domain of the sum of f and g is going to be all of the x values in common from negative infinity up to but not including 5 over 2, and also all of the x values in common from not including 5 over 2 all the way to positive infinity. So really, the domain of f plus g is from negative infinity up to but not including 5 over 2, and from not including 5 over 2 all the way to positive infinity. And the same thing can be said for the difference as well. And the product too. So yeah, the domain of the sum, difference, and product are the one in red. Now in interval notation, from negative infinity up to but not including 5 over 2, it is going to be an open interval like that for this part. Now for the next part, from excluding 5 over 2 all the way to positive infinity, we have to put a union sign in order to be able to go to this next part. While still excluding 5 over 2, we are going from it all the way to positive infinity. So this is the interval notation for the sum, difference, and product of f and g.